Okay, so now we have a rational inequality, and it's similar to solving rational equations, just the only difference is we still have to solve for x, but x is going to be it's going to be a range, and the answer is going to be expressed in interval notation. So basically, the first thing I'm going to do is I'm going to take this side and move it to this side. Basically, what we have to do here is we have to, well, at least for the time being, we have to figure out when is x less than or equal to 0 on a graph. So the first thing you want to do is you want to simplify this. So the way you do that is, if you want to subtract this, you have to find a common denominator. So the common denominator is x minus 4, x minus 6. And if we're multiplying this by x minus 6, we have to multiply this by x minus 6. And now make sure, well actually, when I do this, I have to make sure that I keep this negative sign with the x plus 4. And if I'm multiplying the x minus 6 by the x minus 4 for that common denominator, I have to multiply the x plus 4 by the x minus 4. And this is going to be less than or equal to 0. So now I just have to simplify here. Okay, so I think I just cut this scene after I fast forwarded it a little bit because I just wanted to save time. So as you can see here, this is what I have right now, and I think I said fast forward around here. So basically I just simplified all the brackets here by doing the double distributive property. But for the x plus 4 times x minus 4, notice how after I distributed everything, so we get x squared minus 16, I multiplied everything by the negative sign here too. So we can see that down here. And after I did that, I just simplified the numerator, and this is what I got. So now what I'm going to do is, I know that the denominator is factored, so I'm not going to touch that. But I'm going to factor out the negative 4 because it's not factored yet. Now, this is getting closer to what we want, but I don't want this negative 4 here because this makes things complicated, and it makes things a little ugly to see. So what I'm going to do is I'm going to divide both sides by negative 4 to get rid of the negative 4. But notice how, since I'm dividing by a negative number, I have to flip the sign of the inequality. So the result of divided by negative 4 is going to be x minus 1 over x minus 4 times x minus 6. 0 divided by negative 4 is just 0. But now I have to switch the sign of the inequality because I'm dividing by a negative number. So now, initially, when I said earlier, we have to figure out when is x less than or equal to 0. Now we have to figure out when is x greater than or equal to 0. So that's why I said for the time being back here, I believe. So now we have to find something else. When is x greater than or equal to 0? So now that this is what we have now, so I'm going to erase everything else because I need room to show what to do now. The way we find out when is x greater than or equal to 0 is we create a number line like we did last unit. So I'm going to create a number line. Here's what we have to do. We have to figure out where are the x-intercepts and where are the vertical asymptotes, because we have to label the vertical asymptotes and x-intercepts on this number line. And the way we find that is we find the x-intercepts by setting our numerator equal to 0 and solving for x. So if we do that, we get x equals 1. So we have an x-intercept at 1 for x equals 1. And then for our vertical asymptote, we find the vertical asymptotes by setting our factors in the denominator equal to 0 and we solve for x. So when we do that, we get x equals 4 and x equals 6. So now we're going to plot these points on our number line. And I also believed in class, with interval notation, if something doesn't equal something at a certain point, we put like a circle bracket. So I believe in class we were told to do this because infinity, there's always a circle bracket. And since a graph will never touch a vertical asymptote, it'll only get closer and closer to it. We also put these circle brackets around the vertical asymptotes. So yeah, so now what we do is we have to plug in. So basically what we do here is we have to figure out, so let's go back to what we originally wanted. We have to figure out when is x greater than or equal to 0. And we do that by finding the value of x in between these x-intercepts and vertical asymptotes. So basically what we do here is, if we want to figure out the value of x, if we want to figure out where the graph's going to be between negative infinity and x, we plug in a number between negative infinity and 1 into this formula. And if we get a positive value, we just put positive, and we know then it's greater than 0. And if we get a negative value, we know it's less than 0. It doesn't really matter what number you get. So I have a calculator here. So I'm going to just plug in 0, because 0 is between negative infinity and 1. So if you plug in 0, you just get negative 1 over 24. I should have realized that before plugging this into the calculator, which is a long decimal number. That's negative. So I don't care that it's a decimal. It's just a negative value. So I'm going to just put a negative sign here to show that the graph is negative in between negative infinity and 1. And I'm going to do that for all of these. I'm going to do that for all these intervals, and then I'll come back. Okay, so basically, I plugged in a number between each of these intervals to figure out where the graph was when it was between those intervals. So this is what we get: positive here, negative here, positive here. So now what we're going to do is, it's very simple. We're going to write our answer out in interval notation. So basically, when is x greater than or equal to 0? Well, x is a real set, or is an element, sorry, x is an element of numbers. So when is it greater than or equal to 0? Well, it's not negative infinity and 1, because it's a negative there. It's less than 0 there. Now, notice how it says equal to. That means if it's equal to 0, that counts as an answer. And at an x value of 1, that's an x-intercept, as I said over here. So it can equal, so at 1, the graph can equal 0. So because it can equal 0 at 1, we can put a square bracket here, and then put a 1. And then we put a comma, and then, now notice how it's only positive between 1 and 4. Now notice how it's equal to 0 at 1. But even though 4 it's part of the same interval as 1, notice how this graph or this equation can't equal 4, because at 4 we have a vertical asymptote. What we're going to put is 4 in a circle bracket. And where else is it greater than or equal to 0? It's also greater than or equal to 0 between 6 and infinity. So notice how 6, there's a vertical asymptote. Sorry, we have to put the and sign that stands for and. Like this circle bracket, because there's a vertical asymptote at 6. And then it's infinity, it's above 0, it's greater than 0 all the way to infinity. So we can put positive infinity. So basically, when is x in this equation greater than or equal to 0? Well, it's greater than or equal to 0 here. This is our answer.